All right, let's take a look at implicit differentiation. We've been doing derivatives of things that can be written explicitly, like y equals 4x squared minus 3x. So when you do the derivative of that, a lot of times you're going to be using things like the power rule. On this one, we'd get 8x minus 3, and we'd be done. All right, but sometimes you have a situation where the relationship you're looking at cannot be written explicitly with y on a side by itself because, for instance, there's a y in both of these terms. So you can't get it to where y equals, and then over on the right-hand side, everything just has an x in it. That's why you need implicit differentiation, okay? So the steps are there when you need it, but here's the big idea. We are finding dy dx. So we're finding the derivative with respect to x, okay? Some terms just have x in them, like in this case, the 3x squared and the 5x. Well, the derivatives of those terms are going to be just like usual, okay? But when you're finding the derivative of something that has a y in it, you're going to get a y prime, okay? So terms with a y in it, a y in them, will have a y prime when you find the derivative. Because we don't know explicitly what it is, but because think of y equaling something like 3x squared plus 1. So when you wind up doing the derivative of a term that has a y in it, you would have had to do the derivative of this inside function. Okay, so let me show you what I mean. So on y squared, you'd use the power rule and do 2y to the first power, but then y is something like 3x squared plus 1. I just don't know what it is, so I need to make sure I do the derivative of y. The derivative of minus 2y would be negative 2, but then it's a y, and I'm trying to do the derivative with respect to x, and so I would need to do the derivative of that inside function on that term as well, which would be y prime. Now make your prime kind of slanted, and don't ever write y to the first power if you're going to do y prime instead of dy dx. All right, now the derivative of 3x squared is just 6x, derivative of 5x is 5. Now circle the items that have the y prime in them. They'll stay where they are. So we have 2, let me write that a little better. So we have 2y prime minus 2y prime equals 5 minus 6x. And then that y prime can be factored out now of those two terms. It is a common factor. And then you can now get the y prime by itself by dividing by the 2y minus 2. And there you have it. So what's different is your answer has both x's and y's in it. You see that? Okay, you haven't had that before. Okay. Now there's other equivalent ways you might see things written. So be aware, for instance, that this would be the same as negative 6x plus 5 over 2y minus 2. Little things like that. When you go to check your work, you might think you're wrong, but you're really not. All right, now if you prefer the dy dx notation, there's reasons why that might be good to do. It just gets very tedious, and I think people already are struggle with the tedium of writing so much, so that's why I like the y prime. But again, if you're going to use y prime, don't ever write y to the first power. That way you're not going to get confused about what you mean. All right, let's go ahead and do a couple more. So here's a nice one. I could actually get that written in explicit form, but they're asking me to do it implicitly. So I'm going to do the derivative of x squared, which would be 2x. Derivative of y squared would be 2y, but remember, y is something like 3x squared plus 1. We don't know what it is, but it's some function of x. So you have to do the derivative, you have to use the chain rule and do the derivative of the y. And then the derivative of a constant would be 0. So leave the y term with the y prime in it on that side and move the 2x over. And then get that y prime by itself by dividing by negative 2y. You'd wind up then with y prime equaling x over y once you knock out the common factor. Okay. Number 2 is similar to that, just a little bit harder. You'd wind up with 6x squared plus 9y squared times y prime, because y, you have to do the derivative of the y as well, equals 0. Leave that, okay, where it is. Subtract the 6x squared from both sides, and then that's times there, so you can divide by 9y squared. And that gets you to y prime equaling, I'll simplify the negative 6/9 to negative 2/3 x squared over y squared. So it's negative 2x over 3y squared for my final answer. Okay. Now, this next question, I think I have time to maybe do it. Let's do one more and then I'll stop the video. This one is going to involve the product rule because you have an x squared, and then remember to think about y as being something like 3x plus 1. So you've got the product of two functions that have an x in them. All right, so be careful when you do this. So we're going to wind up doing the derivative of that. So it'll be 2x times y as is plus x squared times the derivative of y. Okay, and that wound up not taking as much space as I thought. All of that's just the derivative of the first term. Now I'm going to work on the derivative of the second term. So it's going to be 2y times y prime times the x plus y squared times 1. All of that is the derivative of, of the second term, and then the derivative of a negative 2 is 0. So this would be 2xy. Now I like to just clean it up a little bit first. Ooh, let me do a better job. That would be 2xy plus x squared y prime plus 2y prime. Oops, let me put the x where I like it. 2xy prime, that's that whole term. It's all time, so I can just reorganize things. And then plus y squared, okay? And that's equal to 0. So then I have these two terms with y's in them that are going to stay put. And the other two I'm going to subtract over to the other side. Then I'll do that factoring out step since the y prime is in these two terms. And then at that point, I'm going to divide both sides by negative 2. No, I'm not negative 2. Divide both sides by x squared plus 2xy to get the y by itself. Okay? So y prime would equal this right here. Now, it kind of looks like maybe there's stuff you can cancel, but remember you can only cancel things that are factors of the whole numerator with factors of the whole denominator. And like in the numerator, I could take out a y or a negative y, and I would have a positive 2x plus y left. In the denominator, what's common is an x, and I would have an x plus 2y. So really, either of these would be okay. Okay, the factored form or the form that was all multiplied out.